This project is a TV glare simulator. The idea is you're sitting in the living room looking at a TV, and I wanted to simulate how sunlight coming through the window creates glare on the screen using cube-mapped reflections. The core here is a cube map. I render the entire room, walls, floor, ceiling, windows onto 6 faces of a cube texture from the TV's perspective. Then on the TV surface, each fragment computes a reflection vector based on the view direction and the surface normal and samples that cube map to see what's being reflected. So when you move around the room, the glare shifts on the screen because the reflection direction changes. That's the whole point of environment mapping. The TV screen itself is a tessellated curved mesh, like a Samsung curved TV. You can control how curved it is with a slider. A flat screen reflects uniformly, but when you add curvature, different parts of the screen have different normals, so each fragment reflects a slightly different part of the room. That's what makes curved TVs more susceptible to glare in real life. For the windows, I'm rendering them as HDR emissive surfaces. Their color values go way above 1, which simulates bright sunlight. That HDR data gets captured in the cube map, and when the TV reflects it, I use Reinhardt tone mapping in the fragment shader to bring it back into the displayable range. You can toggle windows on 3 walls and see how the glare changes depending on which direction the light comes from. I also implemented 8 different anti-reflective coatings that you can compare. These range from bare glass at 4% reflectance all the way down to moth eye nanostructure at 0.1%. That one is inspired by actual moth eyes that have nanoscale bumps to eliminate reflections. In the simulation, it reduces the reflectance multiplier to near 0. It models the result of nanostructure rather than the physical cone arrays themselves. The matte finish scatters the reflection by sampling the cube map at higher MIP levels, so instead of a sharp glare spot, you get a diffused glow. The polarized filter has angle-dependent behavior based on Brewster's angle, so the glare doesn't just get dimmer, it actually changes character depending on the viewing angle. The time of day slider moves the sun position, which changes both the direct sunlight intensity and where the sun disk appears in the window. At night, there's no sun, so no glare. At noon, it peaks. Everything updates in real time. The room geometry rebuilds, the cube map re-renders, and the TV reflection updates. Thank you for watching.